Hi, 7th graders. We're on lesson 9.3, which is linear functions. It starts on page 475 in your textbook. Our learning target is being able to represent linear functions using function tables and graphs. So a linear function is a function that when you graph it, it forms a straight line. So we talked a little bit about functions in lesson 9.2, and remember a function can be written like f of x equals 2x plus 3, and then whatever x is you would put in for x. So that is a function. If it forms a straight line, which this one would, then that would be called or considered a linear function. So you will see in a few minutes here an example of a linear function after we graph it. So if we look at this word problem, the school store sells book covers for $2 each and notebooks for $1. Tony wants to buy some of each. The cost of X book covers and Y notebooks is 2X plus Y. Tony has $5 to spend, so 2X plus Y equals 5. Graph 2X plus Y equals 5 to find out how many covers and notebooks Tony can buy. So we have our equation to figure out how many notebooks and book covers Tony can buy. So we have 2x plus y equals 5. Okay, in order for us to create a table and a graph, we have to write it in the form of a function. F of x is also the same as y. So you can see we have an x and a y in our function. So we're going to rewrite 2x plus y equals 5 in a y equals form. So 2x plus y equals 5. So we are wanting to get y alone on one side. So in order to do that, we need to get rid of 2x. Because it's being added to 2x, we're going to subtract 2x. And we're going to do that to both sides. So 2x minus 2x cancels out because that's 0. So we're left with y. We bring down our equal sign. 5 and 2x are different units. They are not like terms at all. So we cannot combine them. So it would be y equals 5 minus 2x. So that is our function. That is how we would write it, and it's the exact same equation as 2x plus y equals 5, but we're just rewriting it in order for us to create our table. So this is a function table. We have our x and we have our y, and if you remember from 9.2, we put our function in here. So we know that y equals 5 minus 2x, so I'm going to put 5 minus 2x into here. Okay, so I'm literally taking this, oh, why didn't it circle for me? This and putting it right there. Okay, so now we can pick any values of x because there's infinity amounts of x that we can put in for our equation. We're going to keep it somewhat simple and go with 0, 1, 2, and 3. You could go 0, 2, 4, 6. You could go 0, 5, 10, 15, whatever you want to do. It's easier to graph when you have closer values of x. So then we take our x value and we rewrite our equation with the x value in it. So this should be review from 9.2. See how I replaced x with 0. Then this would be 5 minus 2 times 1. This would be 5 minus 2 times 2. This would be 5 minus 2 times 3. Okay, so 5 minus 2 times 0, so we do multiplication first. 2 times 0 is 0, so 5 minus 0 equals 5. 5 minus 2, because 2 times 1 is 2, is 3. 5 minus 4 is 1, and 5 minus 6 would be -1. Okay, our x, y, so this is our coordinate. So we take our x value and we take our y value and we make it into a coordinate point. So this would be 0, 5. So this tells us that when x is 0, y is 5. Okay, so then this would be 1, 3. And we always write it with the parentheses and then a comma in between the two numbers. We have, 2, 1, and then 3, -1. Okay, so all of our x values, 0, 1, 2, 3, all of our y values, 5, 3, 1, -1. Then we take our values, or our coordinates, and we come over to our graph and we graph them. So 0, 5, 0, remember this is x, this is y. So we do x first, so 0, and then up 5, so 1, 2, 3, 4, 5. Here's our first point. Then we have 1, 3, so over 1, up 3, 1, 2, 3. Here's our next point. Over 2, 1, 2, up 1. And then 3, -1. So 1, 2, 3, down 1. And then if we connect them, we don't need all the points in our line, but we do know that, oops, I want to make this, okay. Once we have at least 2 points, but here we have 4, then we should be able to create our line, and we know that it will go on and on forever. So I'm going to connect my points like this, and it will keep going on and on. And then we want to have our arrows, oops, so that we know it's a line. So it goes on and on. So because it's a straight line, it is a linear function. This is a function. This is the line of the function y equals 5 minus 2x, or you can write it as f of x, so the f of x is the same as y, equals 5 minus 2x. Okay, so you have your equation, and then you make your table, you figure out the coordinate points, and you put it into the graph. So there's several different ways to represent a function. An equation, a function table, coordinate points, and a graph. Okay, I want you to pause me and graph this one, y equals 2x plus 1. I want you to fill in the function table, and then I know you don't have graph paper, but just do it as best as you can in your notebook, so then when I do the line, you can compare your line to mine. Okay, so we take our 2x plus 1, and we're going to put it right into here. So 2x plus 1. Okay, I'll do 0, 1, 2, and 3 again. If you used different ones, that's totally fine. They'll still match up to our line, so we still would have the same exact line. So we would have 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1, and 2 times 3 plus 1. 2 times 0 plus 1 then is 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. And this would be, 5. 2 times 3 is 6 plus 1 is 7. Okay, so then we have 0, 1, 1, 3. 2, 5, and 3, 7. So I'm going to go over to my graph then and graph it. We have x and y. Yes, that's a y. So 0, 1 over 0 up 1. And then 1, 3 over 1 up 3. Over 2, 1, 2, 3, 4, 5. Over 3, 1, 2, 3. Up 7. So we have 5, 6, 7. And then we would do our line. If you did, say you put 10 in for x, 2 times 10 is 20. Let's not do 10. 2 times negative 4. Let's do that. 2 times negative 4 plus 1 would be negative 7. So our coordinate point then would be negative 4, negative 7. So we would go 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. If I counted right, 1, 2, 3, 4, 5, 6, 7. Because 2 times negative 4 is negative 8, and then we add 1, so it's negative 7. Okay, so I wanted to show you that it would be on our line. So let's add our point. So then we would go draw our line like that, and it is almost right on, just only because my dots are just a little off. So then our line would go both ways without that dot in the middle, but it's just easier for me to draw it like that. Okay? So you have your equation, table, and graph. If you are still confused, there's still a couple more examples in the book. Okay? I want you to do this one. Actually, no, we're going to skip this one and we'll do that one in class tomorrow. All right, and our last example here. Which line graphed below best represents the table of values for the ordered pairs x, y? So we're given a table and that our pairs are lined up just a little bit differently now. So we have our x's horizontally along the top and then y's horizontally along the bottom. So our point, one of our points is actually, it would be these numbers right here. So instead of looking from left to right, we're going top to bottom. So one of our points then is negative 2, negative 3. Okay, another point then would be negative 1, negative 1. We also have 0, 1, and then 1, 3. Okay, so it's asking us which graph represents this table of values. Well, we can take any one of these points and find it on each graph. First, we want to make sure that at least one of the points is on the graph. So we can see here that we have, I'm going to do 0, 1 because it's an easy one to look for. So 0, 1, you would go over 0, up 1. So we know that this one could be a possibility. We also have 0, 1 right here, so that would be a possibility. Over 0, up 1 is right here, so that's not on our graph. Over 0, up 1 is right here, and that's not on the graph either. Okay, so now we have, now let's look for negative 2, negative 3. So we would have over negative, or to the left 2, so 1, 2, down 3, 1, 2, 3. Well, that's right there. Actually, I'm going to make our points that we're checking. And then we have 0, 1, we already checked that one, negative 2, 1, 2, 3, negative 3 is right there. Okay, and then we don't even need to check these because we already know that 0, 1 isn't on here. And we can, even though we can look and see that we have negative 2, negative 3 right here. And then we have negative 2, negative 2. So this one is just totally out, not even close. Okay, negative 1, negative 1. Over 1 to the left, down 1. Over 1 to the left, down 1. I think this one might be our match. Over 1 to the left, down 1. Notice that I'm always starting at the origin when I'm counting to find my points. Okay, I know that we've done this over and over and you learned that forever ago, but you always need to start at the middle, and then that's when you start counting how many to the left or right and then how many up or down. And then our last one is 1, 3. So we'll just go right to this one and make sure that it matches up. So we go over to the right 1, up 3, 1, 2, 3, and it's right on. So this one is our graph because it has all of these points right on our graph. Okay? We will soon learn how to then write our equation based on this graph. But for now, we're just working on equations and then creating the graph, and with ordered points, finding the graph. Okay, so that is all I have for you for 9-3. There's a lot more information in the textbook, and make sure you go into NICU and take your 9-3 quiz. Have a super evening.